In the previous lesson, we were looking at trigonometric ratios and angles to find sides. Now we're going to use what's called the inverse of a trigonometric ratio to find angles when we know the sides. An inverse, you've been dealing with that for a long time. The inverse function for, say, multiplication is division. So it's something that undoes the previous function. More famous example, I would think, is like the square. If I were to square 3, I would get 9. If I wanted to get back to 3, I would have to do a square root. So square root is the inverse of squaring. So in this case, we're going to undo the trigonometric ratios we had before. So if you know the sides of a triangle, you can use the inverse trigonometric functions to find the measure of the angle. You can see here the original function is sine of A is x. Well, if you do the inverse sine, and that's what we say inverse sine of x, then you get back the measure of angle A. Usually when you're using a calculator, you'll want parentheses around this. And remember, x is not an angle. X is actually the ratio of the sides of the triangle. So in this example, I have a 5, 12, 13 triangle, and the angles are approximately 23 degrees and 67 degrees. In this case, I already know the degrees, so we're just trying to get some practice in what goes with what on the inverse function. Here it's saying tangent of angle A is 5 over 12. Well, you need to remember what tangent is, and here I wrote it on the side. TOA, part of the SOHCAHTOA. Tangent is opposite over adjacent. Well, the opposite, if 5 is the opposite, it's opposite to 23 degrees. And the 12 is adjacent to the 23 degrees. So if I go backwards to get the angle, I know that angle A is 23 degrees. The way I write this as an inverse function is I just say tangent with a -1 there of 5/12, notice the parentheses, and I basically get the same thing, the angle, 23 degrees. Now they want to know, and remember, A is not any particular angle in here, it's moving around. So they tell me this time that tangent of angle A is 2.4, or 2 4/10. So the side needs to be opposite. Now the hypotenuse is not allowed to be the opposite or adjacent side. It is only the hypotenuse. So in this case, this is going to be more than 1. So I'm actually going to see if 12 over 5, that would actually be 2.4. So that would be the 67 degrees. And the way you write it again is tangent inverse, -1 exponent there, of 2.4, 67 degrees. On cosine, I know cosine of angle A is 12 over 13. Cosine is adjacent over hypotenuse. So there's my hypotenuse, the 13. If 12 is the adjacent, it has to be the 23 degree angle. And then you'll see that when you write it as the inverse, that's how you would write that. Cosine inverse of 12/13 equals 23 degrees. Then finally, the sine of angle A is 12 over 13. Sine is opposite over hypotenuse. And remember, you can use your math chart. You don't have to memorize these, but it is helpful if you do. So if the opposite side is 12 and the hypotenuse is 13, that means that angle A, in this case, is 67 degrees. Now, how do you find angles using the inverse trigonometric function? Here's some general steps. First of all, make sure your calculator is in degrees, not radians. And your calculators default to radians, so don't be surprised if there's a memory clear, you're going to have to hit mode and go change that radians back to degrees. It should be the second line down on the calculator. Now highlight a known side of the triangle. Is it the hypotenuse, or is it opposite or adjacent to the angle you're looking for? Then you want to highlight a second known side of the triangle and ask the same question. Once you know if you're dealing with opposite, adjacent, or hypotenuse, then you can find the right trigonometric ratio. Then use the calculator to take the inverse trigonometric function of the ratio to find the angle. And again, using the calculator to find the inverse, you can see here's the sine, cosine, and tangent, and the inverse functions here are in blue. What that means is I need to hit the blue second button up here to get to those, and press the trigonometric function you need. So there's the second button that you press. And then you're going to do either sine, cosine, or tangent. So it's one of these right here. Then enter the ratio you found above and press enter. Although you might actually want to hit close parentheses before you hit enter. And that's pretty much it. Then we'll practice this in class. Now in example 2, I want to find all of the missing measures. So any missing sides and the missing angles. Angle Q I already know is 90 degrees because I have the nice little square there showing it to me. I'm missing this side, and I'm missing angle R and angle P. First of all, I'm going to start with what I'm really familiar with. I have two sides of a right triangle, so I can use Pythagorean theorem to find x, and that's what I did right here. 6.7 or 6 7/10 squared plus x squared is 8.3 squared. Now, a really common mistake that we've been seeing since pretty much the beginning of the year is everybody wants to put the x squared in the hypotenuse side. Make sure if it's not the hypotenuse, it needs to be added to the other side, and the square of it needs to be added to the other side. I went ahead and subtracted 6.7 squared from both sides, and then I found out what those numbers were. I could have squared it first, but I didn't want to pull out my calculator yet. And then x squared was 24. But I'm not looking for x squared, I'm looking for x. So I have to use the inverse of a square, which is a square root. So x is square root of 24, or in this case, 4 90/100ths. Now I'm going to go ahead and look for one of the angles, angle P. I know the adjacent side, and I know the hypotenuse. The trigonometric ratio that uses adjacent and hypotenuse is cosine. So I can say cosine of angle P is the adjacent over the hypotenuse, 6.7 over 8.3. But I'm looking for the angle, so I need to use the inverse trigonometric function. So I take inverse cosine of the ratio, and that will be the angle P. In this case, that's 36 degrees. Now I'm going to look for angle R. For angle R, I know the hypotenuse, and I know the opposite side, opposite that angle. So opposite and hypotenuse, that is the sine function. So I can say sine of angle R is 6.7 over 8.3. Use the inverse trigonometric function to go back and find the angle, and I find it's 54 degrees. In example 3, as part of off-season training, the Houston Texas football team is building a ramp, and it has a 28% grade. And they want to know to the nearest degree what angle does this ramp make with a horizontal line. When it says a percent grade, if you've ever been driving, I know here it's kind of flat, but if you've ever been driving on a steep mountain or been hiking on a steep mountain, you might see a percent grade sign on there. The percent grade does not mean angle. It refers more to a ratio of whatever this number is to 100. So percent grade is just the rise over 100. And if I draw a picture of it, so I just put a 28 over 100 as my two sides, that's fine. It doesn't have to be, you can just use the percent and assume this side's 100. And I'm looking for this angle right here, angle A. I know the opposite and I know the adjacent. The trigonometric function that goes with opposite and adjacent is TOA, tangent. So I set up tangent of A is 28 over 100. Take the inverse tangent because I'm trying to find an angle. And the calculator gives me this big long number. I want it to the nearest degree. So I underline the ones place and circle the tenths, and I need to round up to 16 degrees. Now we have example 4, the last one. A right triangle has leg lengths of 28 and 45, and they want to know if the length of the longer leg doubles, what happens to the measure of the acute angle opposite that leg? So opposite this 45 inches when it becomes 90 inches. So first thing, draw a picture, and I know that 45 is opposite, and 28 is the other leg, so it can't be the hypotenuse, it needs to be the adjacent. Opposite and adjacent is tangent. So tangent of this mystery angle, which I called A, is 45 over 28. If I want to find the number of degrees, I need to use the inverse tangent, and that gives me 58 degrees on my calculator after I rounded. Now I'm going to draw the triangle which has the longer leg on it, 90 and 28. It's still the same function. The numbers change though. So when I take the inverse tangent, First of all, tangent of B is 90 over 28. Now I take the inverse tangent of 90 over 28, and I get 72 degrees. So what happened? My angle increased by 14 degrees, or if you divide 72 by 58, it's a factor of 1 and 20 hundredths.